So, hey guys, today we are going to look at the NPin problem and we are going to build a visualizer for that problem. So, first of all, I'll explain you the problem and then we'll go into building the visualizer. So, basically this problem is that you have a n by n grid, so a square grid, and you have to place a queen in each of the rows of this grid. So here I have, for example, a 4 by 4 grid, and we have to place a queen in each of the rows of this grid. So one queen here, one here, one here, one here. So firstly, we look at this. So in the first row, where can we place a queen? So we can place a queen right at the start, right? There's nothing stopping it. We have to place queens in such a way that each queen should be safe, meaning that each of the placed queens should not get cut by any of the other queens in our grid. So the first queen can directly be placed here. Okay, so let's place the queen right here. So okay, one queen is placed over here. So now let's come to the next row. So here we can't place a queen here because this queen does not allow that. Then we can't place here because this queen again can does not allow that. So the queen can move in all diagonals backwards and forwards uh, and down and sideways. So this is the movement of the queen if you don't know. So we can't place a queen over here because of this. We can't place a queen over here because of this. What about here? Nothing blocking from this side, nothing blocking from this side, nothing from here. We can place a queen over here. Okay, the queen is placed. So let's come to the next row. We can't place a queen here because of this queen. We can't place a queen over here because of this queen. Again, we can't place over here because of this queen, and we can't place over here because of this queen. So we can't place a queen at any of these boxes. So now we have run into a problem, right? So what do we do? From here we backtrack. So backtracking is where we go back and try to solve this problem again, basically. So we backtrack one step, we go back to this our second row, okay, and we move this queen over here. Now we come to the next row. We can't place a queen over here. We can place a queen over here. Nothing blocking from here, nothing from here. All of these are empty, and nothing from here too. So let's place a queen over here. Now let's come down to the last row. We can't place a queen over here. We cannot place a queen over here because of this queen. Again, we can't place over here because of this queen, and we can't place over here because of this queen. So again, we have run into the same problem. Now we backtrack one step. We come over here. Now can we place a queen over here? No, because of this one. Then can we place one over here? No, because of this one again. So now we have to backtrack again and we come to this row. Now can we move this queen forward? We cannot. So we have run into another issue that we have run out of spaces. So what do? We backtrack again. So we backtrack again, we come to the first row. What about this queen? Can we move this queen forward? Yeah, we sure can. So let's do that. So now our whole grid is cleared. This queen has moved forward one step. Now let's come to the next row. Can we place a queen over here? No. Can we place a queen over here? Again, no. Can we place a queen over here? Again, no. What about this one? We can place a queen over here. Nothing blocking from here, nothing from here. Okay, so let's place our new queen over here, right? Now let's come to the next row. What about this place? Nothing blocking from above, nothing blocking from the diagonal. We can place a queen right here. So let's place one over here. Then let's come to the next row. Can we place a queen over here? No. Can we place a queen over here? Again, no. Can we place a queen over here? So nothing on this side, nothing on this side, nothing on this side. Yeah, we can place a queen over here, right? So this is our final solution. We have a queen in each of the rows of our grid, and all of the queens are safe, so none of them can cut each other. So yeah, this is basically the problem in a nutshell. So before proceeding, I'll show you the visualizer that I've already built. We'll take a look at that before we proceed. Okay, so let's come over here. I'll just, so this is our grid, and when I right click, this runs the visualizer. You can see we are trying over here, and it's glowing in red whenever we have a blockage. So we'll let the visualizer run so you guys can see. As you can see, it just backtracked and we're solving it again. So yeah, so this is our final solution as shown in the example that I explained. This is the final solution over here, and yeah, so this is the visualizer that we're going to build today. So what we're going to use for it, we'll use PiGame, and so yeah, if you don't have PiGame installed, you can all do CMD. Oh, sorry. Okay, it opened. And you can do pip install PiGame, and this will install PiGame if you do not have it. Rest we are not using any other library for building this. Only PiGame is required, additional as in additional libraries. And yeah, so if you don't have PiGame already, please run this command. This will install PiGame in your system. So let's get started. So firstly, we'll import PiGame, right? Then I'm defining this as a global variable. So this will define the width of our window that is opening. So let's say 600 over here, and we'll define the number of rows that we want, right? And we'll, let's say 4 while starting. You can change all of this according to how many queens you want. So the number of rows will define the number of queens in the game. So whatever value you put over here in the third row will define the number of in the third line of code will define the number of queens that are going to be in the game. So let's firstly create a window. I'm defining this as a global variable. So this will be pygame dot display dot set score mode, and we'll pass in our width. So this is a tuple that it accepts this function, and because we want a square window with a square grid, I'm going to use width and width as the as our coordinate, as our like width and length of the window, right? And let's also set a title window for this. Like on the top, when you run the code, it shows. So that we're going to set over here. It shows the name of the window. I'll explain you this right after this, and we'll name this and queen visualizer. I think that that's just a good name, just a simple name. Yeah. So this is this. Wait, I just want to show you what this does. I've already built the code, of course, so I'm just going to run it, and I'll show it to you. So you can see right over here it shows n queen visualizer. This is set by this line of code. It's set caption, right? So that is what I wanted to show you. And yeah, so you know what? I'll just keep that open just because if I want to run the visualizer again to show you guys something, I'll just keep that open. So now we want to define our colors. So you see, while the code was executing, there were different colors like black, blue, green, and red whenever it was colliding with another queen, right? So firstly we want to set that up. So, these are RGB colors, and they range from 0 to 255. So I think you guys understand this. So like for the red it is 255, 0 and 0. Then for green it will be 0, 255 and 0. And then for blue it will be 0, 0 and 255, right? And then we'll also need white, which will be 255, 255 and 255. And we'll also need gray for building the grid. Hmm. I'll explain all of this later, like all these colors, where they'll be used and how they'll be used. Right. So these are the colors that are required for this. Now, first of all, we want to build each of the blocks. So like when the code was running, you could see a black block and then blue blocks moving, right? Like I'll just run the code and show it to you. So like these are different blocks, and you can see when the code is running. So like this is the black blocks, this is the green. So I'm going to call all of these spots. So these are the different spots that are rolling around in our window. So like as the code is running, okay, I've made the code such a way that you can't stop the execution once it started. So we'll have to wait for this to finish, right? So you can see all of these are spots. We are going to call this spots, right? So first of all, we'll create a class spots. Let's call it spot because each one of them is a single spot, right? And then we'll do our init. We'll not do it this way. We don't want a return type. What we do want is a row, a column, the width, and the total rows. So the total rows, and this part I'll explain it to you as we go. Firstly, we'll do a little self dot row equals to row. I'll just get quiet for this part because it's just repetitive code. So the default color, we are going to keep it as white. So whenever a new spot is initialized, the default color will be white itself. And one more thing that we need is the x and y axis of each of the spots, and we will do that calculation in this class itself. So we will create a self dot x. So let me explain you this. So like each spot has a coordinate, right? This is like, let's say 0 0, this is 0 1, right? So each spot has a pixel coordinate of where it should be placed, and that is going to be calculated using, we can do a simple calculation like row into the width of our window, right? This will give us the x coordinate, and for the y coordinate we will do column into the width. So this will give us our different mm, our x and y coordinate for each of the spots. And this class is going to have a lot of functions. So let's define all of that. So firstly, we'll have a get position function to like get the position of a particular spot. I mean, I don't know if we'll use that, but mm, I'm just going to make it because just having it might come handy later. Will returns the row and the column. Now the next thing we need is a different is function. So the spots are going to have different states, right? So a spot could be closed. So closed would mean that there is a queen already placed in it. A spot could be a checking, like it is being checked if it can be placed or not. And uh, a spot could be open, or a spot could be in the process of being checked that is it possible to place a queen at that spot or not, right? So we are going to need functions for all of that to to check that is this spot open or closed, right? So let's just make these functions. Okay, now we are going to make this red. And have we defined black in the code? Oh, we have not defined black. So let's just do that very quickly. Black is 0 0 0. So uh, so is closed, we're going to keep it as red. Is current, we are going to keep this one as green. So these are checking conditions, they'll return boolean values, right? So basically this is current is for checking that is the current spot, like the spot that we're checking. So this is the new spot that we're checking. So this is the current, like what we're naming it this way. So a barrier would mean that there's a queen placed in this already. We'll make this black, and it should be double equal to it. And apart from that, do we need anything else? uh, yeah, we do need, of course, f is score checking. So so this is like if we're like in the process of checking if uh, like different paths, if they are okay or not. I'll explain you this just a second. We'll make this as blue. So let me just explain you this blue thing. So like this green is the spot that we are checking, and the blue is like I'm visualizing the paths that it is checking right now. So as you can see, like this is checking all of this is checking over here, and then like this. So that is the blue thing that I'm visualizing over here. So that is used for that purpose, right? So yeah. So this is this, and then we have to Uh, I don't like the naming that I'm using right now, but is reset will check if the spot is white. That means that the spot is open, right? So let's just do this. Now, using these functions, we can get the states of all the like of the different spot. So we can know if it is closed, it is current, it is barrier. Now we also need functions to make the spot closed or current or barrier or checking or reset, right? So let's just copy all of this, right? And where do we end? Yeah. So let's make this mm, make, if I can type, make closed, right? And just remove one of these and remove the return, and make current and make barrier, and make checking, and make reset. This could be just called reset also. I'm just going to keep the naming scheme constant throughout, so I'm just going to name it make reset just because I want to keep the naming scheme just the way it is. So this is basically our states of a spot managed. We can get the state of a spot and we can make changes to the state of a spot, right? Now there's one more function that we need, and that is the draw function. So the draw function will basically draw this spot on the PiGame window. So we need to pass the window for that, and we will use PiGame dot draw dot rectangle. So rect is that this will accept the window, and the color we'll keep that self dot color, so whatever the state would be currently, and we'll need to pass a tuple with the xy coordinate and the width and the length of the spot, right, of the rectangle. So we'll use self dot x, self dot y, and self dot width, and self dot width, as we are going to keep it rectangular only. So we'll use width only. So it should be dot. So yeah, this is basically our spot function done. Now what we need to draw the grids. So now we are done with the spot function for spot class, and now the thing that we need to do is we need to make the grid that we are visualizing. So we need to make this grid, right? So I'm going to divide this within two functions. So the first one would be the function that makes the grid, and the next one would be the function that draws the grid. Okay, I'll directly get into it and I'll explain it as I go along. Okay, the first function is the make grid function, and we need the row, and I'll just keep it rows because of the global variable, just because to differentiate, even though Python is not a case sensitive language. Python is a case sensitive language, I'm sorry. So it wouldn't matter, but still. So we're going to have this empty array, and we are going to find the gap. So this will be width divided by row. So this gap is the amount of gap that exists between each of the lines. So basically, like this gap, this is defined by this, right? And we start a loop. So in range rows, and we'll append a empty list inside this grid. So we need a 2D array, right? Like this is a 2D function, like a 2D array, right? So we'll put in a 2D array. So we just do this. And inside each of these we need the spot. So the spot class that we created, we need that. So let's and I'm just going to create a variable to initialize this. And so in the spot, what do we need to pass? Let's have a look. The row, column, width, and total rows. Okay, so let's just do that. So this will be I, J, the gap, and the rows. So this will initialize our spot class, and then we just have to append this in the grid of I dot append spot. I'm just doing this to keep the code clean, so you don't need to. Then we'll return the grid. And the next thing that we need to do is we need to draw this on our function now, on our screen now. I'm sorry. So we have made the grid in this function, and now we need to draw the grid. So here we need our window and the rows and the width. And again we'll calculate the gap using the rows and the width. It will be width divided by rows, and we'll go into the loop. Now we'll use the PiGame library. Like over here we use the rect. Here we'll use the line function in the PiGame library. So we'll do pygame dot draw dot line, and this will accept the when, and we'll keep the color as gray for this one, for these lines. You can keep it whatever you want. I'm just keeping it gray. And then we have to define the starting position and the end position of each of the lines, and we need vertical and horizontal lines. So okay, here we're going to do this, and uh, we'll do this I into our gap. So this is the starting position in coordinates, and then the ending position, which will be our width, and the gap again, I mean I into the gap. And now this is one set of lines sorted. Oh, we need a grid, so we need another set of lines, so a vertical and horizontal lines, right? So we need a nested loop inside this. Again rows, and we'll copy this exact function right here. The only thing we need to do is we need to flip these. So over here it was I into gap, over here we'll do uh, over here we'll do, and this will make it as J. So yeah, so this is basically it. So yeah, this will sort our uh, drawing. And now I'll create a draw function this will be called basically each time that we want to update our screen, we'll call this function. Okay, I'm just going to put pass over here for now, uh, and I'll get back to it. No, in fact, let's make this right now. In fact, let's make this right now only. Yeah, I'll explain it as I go along. We need the grid, the rows, and the width. And first thing we'll do is win dot fill, and we'll fill it with white. This is like a necessary. It is not necessary, but it is just good practice to always do this before. So we'll do that, and then now we'll go into our. So let me explain you. What we need to do is we need to take all of the spots from the grid, and we need to draw it on our screen, right? So in our spot function, we had a draw in our spot class. I'm really sorry, I'm calling it function all the time. In our spot class, we have a draw function, right? And this basically draws the spot at the correct coordinates in our screen. So we'll take advantage of that, and we'll just call the function over the whole grid. We'll need to use a nested loop, and let's call it spot in row, and we'll do spot dot draw, and we'll pass in the window, and then we'll draw our grid. So we have the draw grid function. We'll just do win rows and width. So we are drawing all the spots with their appropriate color and the grid. And now to bring this on the screen, we will do a PiGame dot display dot flip. Okay, so now what this does is like so basically we have two windows, right? There's a PiGame window and your Python window that is running in the backend. So now as we want to display the whole function going, we basically cannot do that because the code is so fast. And so what this flip does is as the backend is updating, it keeps all of those frames in the buffer, and then you can add a delay, and the delay will basically help you uh, go along. So yeah, this is so this will basically help you show the animations. So I'll also show you after removing this weight, and over here you can put in the values in millisecond. So for this animation I'm going to put in 200 seconds, but of course if you have a bigger grid you can lower this down, because like if you have more than 6 queens it will take a lot of time if you keep it at 200 or 300 seconds milliseconds, I'm sorry. Yeah, so this flip basically keeps a buffer of all the frames, and this weight is defining how long each update will be. So I'm making each of our updates as 200 milliseconds. So yeah, and I hope this explains you this. Now our main function. In this we need our win and the width, and we'll make our grid. So in our draw function we were drawing the grid. Over here we'll pass the grid from this main function, right? This main function is our main function basically. So yeah, and we'll initialize a few boolean values that will be helpful for us, and started, keep it as false. So basically what we want is, so once our execution has started, we don't want anyone to quit our execution in the middle. So this started, and these booleans will help us do exactly that. So, and let's start our main function, main loop. While run is true, we will draw. So this is calling this draw function that we have created over here, and we'll pass the window, we'll pass the grid that we have created over here, we'll pass the row, which is the global variable, and we'll pass the width, right? And then I'm sorry, for event in PiGame dot event dot get dot get. So this allows us to look for events that are happening in the PiGame. So if like we want to, like if someone presses the X button on the top, we want the code to quit, right? We want the whole thing to stop. So this run boolean is basically used exactly for that, so that the window does not close while the code is running, while the pygame window is open. So we have to put a if event dot type is equal to pygame dot quit, we'll make run equal to false. So if someone quits the PiGame, we make run equal to false, which basically will stop this while loop and will cause the program to quit. And again, we need to do one more thing, that if started, continue. So basically, if execution is started, do not let someone interfere in the middle and let it continue, right? So this is it. Now to start our execution, because we want I want to have a mouse click listener, which will basically start the execution of the code. So we are going to make that now. Pygame dot mouse dot get pressed, and so 0 is for the left mouse button and 2 is for the right mouse button, basically. Yeah. So yeah, let's make this. So now as this now when someone presses this left mouse button, we'll make this started as true. So this basically means that the person wants to start the execution of the algorithm, and we will create another function, algorithm. Let's say, am I spelling it right? Yeah, yep, algorithm, and we'll pass in the grid. So this function is not created yet. I'll just create this real quick after this. So once all of this has happened, we'll do a pygame dot quit to clean up the pygame window, to close it, right? And we need to call our main function, main, and we'll pass in the win and the width, right? So now let's go back and let's make our algorithm. Now yep. So what did we pass in? Okay, we need the grid, right? So now basically over here we're going to build our algorithm, that the n-queen algorithm that is going to execute this. So before that, I just want to check that is everything working, like is the grid appearing, because we have already drawn that. Okay, let's check this out there. I hope doesn't, yeah, okay, it is working. So this is basically the grid, and yeah, so this is working. Now, okay, let's get back to building the algorithm. So we are having our solution. Okay, I'm going to put a pass over here right now. And before we do this, I want to build a helper functions for this program basically, because a lot of code is required for that, and I want to build that first and then procedurally come back to the main algorithm, like the main algorithm function. So first of all, we need a isSafe function where we are going to check that for a specific position, is it safe to keep the queen there. So in that function, we'll have to check that the upper column, like the rows above, and both the diagonals have no queens in them, right? So okay, let me explain you why this. So like, let's suppose we are checking this position, so we need to ensure that there is nothing, there's no queen in this whole thing, and there's no queen over here or in this or this, like, so yeah, both the diagonals and the above, the column above, right? So let's firstly build that. So I'm going to call it as safe. That's just standard naming. We're going to pass in the row and the column. And okay, so the element, the spot that we're checking, we want to highlight that. Let's suppose you're checking this, you want to highlight this one so that everybody knows that which spot are you checking. Like, how I was showing in green, right, on in the execution. So we want to do that. So now this spot could have any color before. So I'm just going to store the color that was there previously in this spot in a temp variable. Okay, so this is going a little bit against oops concepts, but I think it's all right just for this application. Basically, you should never directly access uh, any of the members like this. You should always have a function for that. But yeah, we're just going to do that for this application, and we're going to make current. Yeah, so make current makes the color green. So this is what we're doing, and we're going to draw this. I'm not passing uh, any of the variables inside, and I'll explain you how I'm doing this when we build this algorithm function. We'll have a proper understanding of how that is happening. And now, firstly, let's get started with building our top top checking. So the first part that I'm going to do is check the above column, is it empty or not. Okay, so for I in range column, so um, so how do okay, we will check if it is closed, okay, let me explain. So each of these have properties, right? So a barrier is a queen. So we're going to check that if any of the elements in the grid is a barrier, and if it is, then we cannot place a queen over here, right? So okay, let's get started. So we put in grid row and I dot is barrier. If it is barrier, then it should return false basically, as you cannot place a queen over here. And yeah, so that's this. And right now I'm not building any of the animations on this. I'm just writing the pure functions. uh, okay, so now as this one is done, we can build the animation now. So if let me just get down here. So if the above is barrier, we want to highlight that in green, right? If we are checking and we have highlight that in red, I'm sorry. If you're checking and we collided with another queen, we just want to highlight that in red, like a small animation, right? So I'm just going to make that happen right now. Sorry, make closed. It should be make closed, right? So we are going to make it close and we're going to draw this, and then we'll make it a barrier again, because if our whole code is set in such a way that it's going to check for barriers, so we need to ensure that we make it a barrier again, right? And we'll draw this. Okay, so now this part is done, and we need okay, we need some cleanup code over here. I'm just going to put that later after our uh, I'm just going to put that later. I'll explain it to you as. So now we need to draw the checking portion. So wait, I'm just going to make this a really quick animation so that it does not take a long time to execute. 20 or 50. Just want to show you what I'm doing right now. So you see these blue lines, right? We want to animate that. So that is what we're building over here. So if a grid is not is current, so basically is current is our the grid that we're checking right now, right? So if a grid is not is current, if a spot, I'm sorry, is not is underscore current, we are going to make it is checking, and we're going to draw this. So each time you see each time draw is called, the whole screen gets updated. So like if you don't want to show some animation happening, then you can just not call this for that moment. Yeah. So that is how draw is working. And now as we have made a lot of is checking, so we need to clean that up, right? So like you have made many of the spots checking, like you have made many of the spots blue. So once the execution for that particular step has stopped, you want to clean that up. So what we're going to do is we're going to run this whole loop again, and we are going to just make all of them reset, right? Same loop as above, and we do not want to change the spot that where we have collided. We do not want to change that one, right? So we'll do a continue for that, and then for the rest we, we make them reset, right? So yeah, and this one will be inside the loop, I'm sorry. And then we do need one outside too, because the last one would be left from this, so we do need to check that also. I mean, we do need to make that also reset. Again, all of this is a lot of exception cases that we are running into, so we need to clean all of these up, and that's why we are doing this. So yeah, now once this has finished execution, we again need to do a cleanup, because this will leave so suppose like your code is running and in middle you like the code ran into a exception case on somewhere else, so it will not clean up the grid for the above execution. So we need to clean our whole grid up each time that we do this. So we'll just do a simple nested loop on the whole grid. We can do it this way, or there are many ways to do this. Okay, why is this giving a okay? Okay, we'll see. We'll look at that. That why it is giving a squiggly red line over there. It's certainly not a good sign. We are inside this function, right? What's the problem? I will look at an indentation thing. Okay, okay, we'll have a look at this. Oh, oh, we are missing an in. Oh, yeah. Okay. So this will basically make all of them reset again, and this will clean up our code. So this was our check for the column. Now we need to write the code for our left diagonal and our right diagonal. So for that, okay, we can do it this way. We can run a loop together using the zip function over here. So we'll take it till 0. So -1 we're putting because there is a +1 correction in the range function, right? We're going to make this. So if you put in -1, it runs till 0, basically, what I'm trying to say. Okay. Yeah. So now let's write this. So yeah, just like the previous function over here, if we have found a barrier again, so we just need to highlight that we have found a barrier, and then uh, we need to change that back and then continue our execution, right? So yeah, let's do that. If it is barrier, then we'll go grid I j dot make closed, and then should be a dot, and then we need to draw that happening. We need another grid I j dot make barrier to reset it back to a barrier. I will draw that again. And now again we need to clean up. So I'm just going to copy this whole function over here, and instead of ij we are going to put as I1 and j1. I'm just going to correct this, and if I1 is equal to I and j1 j, we want it to continue, otherwise we want to reset that particular part. Dot make reset, right? Now we need to do another make reset for the spot that is left behind. 0 column reset and return false. Okay, so let us, I think we'll fix it as we go. And now again we need a cleanup. We need to draw our makings. We need, we need to highlight the path that we're taking. So and we want to draw that. Okay, I don't know why we are running into this indentation problem. Yeah, okay, so the indentation issue is fixed. Yeah, Python has a lot of indentation issues. At least I run into them quite a bit. This will be outside this if. Yeah, So now all of that is fixed. Now again we need to do a cleanup. I'm just going to copy this the cleanup code from above because I just don't want to write the whole thing again and bore you guys. You guys can do that too. Just copy the cleanup code from above. So here we check the upper left diagonal. Now we need to check the upper right diagonal. So we have to do a few changes in the code from above. I'm just going to copy this whole thing so that you guys can even you guys can do that. You just copy the whole thing because there's not much change essentially. I'll explain it. I'll explain the changes. So now we need to go like in this direction. We need to go to the row, right? And the rest is the same. Overhead also we need to change to row, as now we need to move forward and up. Firstly we are moving backward and up, now we need to move forward and up, right? So that is basically the only change that we need to do. Let me just have a look at, is there any other change that we need? No. That's all we need. And again we need to clean up the grid. We're going to copy this one and we're going to put this right here. And now if you remember, on the very start of this function we copied the color and we made it current. So now we need to change that back, right? Now we need to change that back. So we are just going to, okay, if I can type, just going to do that. We're going to do, go to the row and the column dot color and make it equal to temp, same that we copied, and we're going to return true. So if none of the false condition came in, that means it is safe to put a queen there, and we can call this as, we can return a true. So this is our is safe function done. Okay, so now our is safe function is done. So the next step is we need to make the recursive function that makes the call to solve the grid. So let me explain. So we are using a recursive function to go inside and then backtrack. So like it will try to fix a queen for this row, then the next, and for this row, then the next and the next, and whenever it runs into a dead end, it will just return. So it will backtrack that way, and then it will place the queen in the next spot and then do that. Okay, so this is like our recursive function, and the next step is that we'll build this. So let's name it solve in queen. Yep. And this, our draw function will be passed, which I'll explain later how that's working, and the column and the grid of course. And now if column, this is our base case basically that we are building. So if we have reached the final row and the queen is placed, then that means that our problem is solved, right? So return true for that case. So this is our base case done, and now will get into the loop. So for each row, right, we check if the is safe function that we created, is it safe for this spot. So we'll pass in the draw, the grid I, and the row will be I and the column will be column only, right? So if it is safe to put it here, we'll make this place as a barrier. That means a queen has been placed over here. Dot make barrier, right? And we'll draw that. We'll draw that on the screen, and then we'll do the recursive call. Solve in queen, draw grid, and we'll do column plus 1 will equal to true. I mean, yeah, that's not necessary, but yeah, just return true. Uh, so basically, this loop is moving the rows, and this recursive call is moving the columns. So each time the loop iterates, we'll move to the next row, and then for each recursive call, we'll move in the next column. So that is how this is working, right? And so if this breaks, that means that we cannot place uh, a queen over here. So we'll reset that. We'll reset that spot, right? So if this does not return true, basically, right? So we'll listen, we'll reset, and we'll draw that as well, and we'll return false for this function. Just yep. So if this is successful, it will return true from here. Otherwise, it will reset that spot and will return false. So this is the recursive function. That is basically our logic to solve the n queen problem. Now we need to get back to the algorithm. Let me see, like we do not want to do anything else, right, in this. Yeah, that's cool. So let's get back to our algorithm, and in this algorithm I'll explain you how that this draw we are passing as a variable. um, Choosing the lambda functions that are available. So we'll call this function, and we are going to save the result in this solve variable. So we'll do lambda draw, we'll pass in our window, we'll pass in the grid, the row, and the width, right? And then the grid, and we'll pass in 0 as our starting row, as our starting column, basically. Yeah, so we want to start from the very top, and then from the most left hand side, and then go on placing queens in each spot, right? So this is our function call. So we'll just put an if sol just to display something uh, on the console as well. So if sol is true, basically we'll print solution found, and okay, yeah, we can return true. Otherwise we can print solution not found and return false. So yeah, now I think the whole logic is done. Yes. So let's just test this out. Let's see if there are any bugs. Probably could be. It's okay. We can see how it is running. So for sure there are some bugs. There's some. Okay, so I found a mistake. Basically, over here we have to move this forward, right? So by mistake I've done it -1. there should be one, right? So minus one will subtract each time, and one will add each time, right? So from row to row, we want to move forward. So we want to, from row, we want to add on till we reach this capital row, which is our global variable. So I had minus one over here and over here. So just change line 104 and line 1110. So yeah, that was the mistake. Just have a look if there is anything else that needs to be done. Okay, yeah. So let's just test this out once more and let's see if everything runs properly. Okay, no, there are some issues over here. Okay, so we'll have to take a look again. Okay, so I found a mistake. So here I had written I and it should be J. So yeah, it was hiding in plain sight. uh, and over here too, it should be J, right? Wow. Yeah, you do make mistakes like that sometimes. So it should be J and this is J right now. I guess it should work. Let's see. Yeah, so that problem is resolved. Yeah, that problem is resolved. Just backtracked. So you can see this is working perfectly fine now. So I just run through the code once more. And basically, okay, I also wanted to show you that suppose if we remove the wait, so the code execution would go so fast that it would basically get executed within seconds. You see, I'll run it again. So one, two, three, yeah. So that's why we have added this wait so that it stores in the buffer and then we can set the timing of our animations. And so I'll run you through the code once. So this is our main spot class where property of each spot is defined. So the color and where the position would be, that is defined, and there are multiple functions for it. And there's a draw function that basically draws the spot at the specified place. Then let's come down to our making of the grid. So this is the make grid function, which basically defines the, like, it is used to add the spots in the grid, in this grid variable that we are using. So this is a list and this is a 2D list and it contains all the spots, our spot class objects. And then this is the draw grid function which draws the grid. So this is a gap calculated by width divided by rows, and this is to make the vertical lines, and this is for the horizontal lines. And yeah, I'm very wrong. This is for the horizontal lines and this one is for the vertical. Yeah. So and then this is our draw. This is our draw function, and so we fill it with white and then we iterate over the grid, and we use the draw function inside the spot class to draw each of the spots, and then we draw the grid, and this flip is used to update the screen. So basically it updates the screen, and because we have a wait over here, so the rest of the updates will be stored in a buffer behind the in the buffer memory, and as this timer takes, they'll get updated. So I've set 200 millisecond, you can set it to whatever you want. And then this is our main function where we have initialized the grid, and we have taken these two booleans for avoiding any unforeseen behavior, and we have uh, run a loop run which is while it is true, it will the PiGame window will keep on going. So we have drawn the whole PiGame window. So this is the first update, and then we have taken an event. So if someone quits, so this event dot type will get that quit, and it will make the run equals to false, and then this loop will break and the PiGame dot quit will get executed. And if started, continue. So basically once the algorithm has started running, we don't want it to stop, so that's why I've put in this. Or we don't want anyone to click the mouse again and override the current execution. So that's why uh, we have we have put in this. And then this is used to get the mouse click. So pygame.mouse that get pressed, and this 0 is for the left mouse, and if you put in 2, so that is for the right mouse. We'll keep it at 0 only. And so over here we make the started equals to true, and then we run the algorithm. So then coming back to the algorithm, so here it goes into the solve n queen function. It calls the solve n queen function, and we have the draw, which is a lambda. So basically it turns it into a variable which we can call later on, and we pass in the grid, and we pass the initial column as 0, right? So let's come down to our n queen. This is the recursive call. So if the column is equals to a row, it means all the spots have been checked, and we return true basically. And if not, then we go into this, and we run a loop for each of the rows, and we check if each of them is safe. So when we come inside, we make it a barrier. So if it is safe, then we make it a barrier. Making it a barrier means a queen is placed, and we draw it, and we do the recursive call for the next column. So if suppose so this recursive call basically ensures that each of the column in a row is checked. So we want to check this and this. Like if a queen can be placed here, we just move on to the next one. But if it can't be placed, then we check this and this and this. And if all of them fail, then we backtrack, of course. So if this returns true, then we just return true from here, because that's it. For this in this portion, the problem is solved. And if not, then we return, basically we do not return true, and we make the grid reset, and we draw it. And then there is the isSafe function which is getting called. So the isSafe function is basically, so this whole part is to check for each of the column above. So like suppose we want to place a queen over here, then this part from line 63 to line 76 is for checking the spots just above this place, right? Then this is just the cleanup code to clean up all our animations that we have drawn already, so all the colors that we have fulfilled. Then this function is for our left upper diagonal. So we are assuming this spot, and the left upper diagonal is this and this, are these and this, right? So this whole function from line 83 to line 97 is used to check the left upper diagonal. Then this is again the cleanup code to clean all the drawings. Then this is again our function to check the right upper diagonal. So this spot, or if you place the queen here, then this and this spot, or if here, then all of these. So this part of the code from line 104 till line 124 is for the upper diagonal. And yeah, so this is basically the whole code. There's not much to explain. The width you can set, and this row defines the number of queens. So suppose if I set it to 5, then there will be 5 queens. I want to make the animation faster, so I can show you guys this quicker. I can show this to you guys quicker. Let me just find the draw function. So I want to make it, let's say, 70 for this one. So yeah, so now you can see animations are much faster. So this is for 5 queens. I'll not go to 6 queens, it's a very long execution for that, but yeah, you can try that out. And so this is basically the problem. I hope you guys liked it, and I hope you guys will implement it alongside me.